Hello everyone, this is Kyle Mummy, and this is my ENME351 Lab 5 report. Starting off looking at the MATLAB RC simulation code, you notice that the plots are modeled by the voltage across the capacitor equals the voltage in times 1 minus e to the negative t over tau, where tau equals r times c. So you'll notice from the plot that the graph of the 10 kilo ohm resistor reaches the final Vin value much quicker than that of the 100 kilo ohm resistor. And this is due to the fact that when you lower the value of r, you're also lowering the value of tau. So the 1 minus e to the negative t over tau portion of the equation approaches 1 more quickly when the value of r is small. So here is my circuit layout on my breadboard. Digital pin 8 sends in a specified voltage input from the Arduino IDE. This voltage is sent through the resistor, which is in turn passed to the capacitor. On the positive leg of the capacitor, we have a wire attached to analog input A0 to read the voltage that is being passed through the capacitor. IDE code. Above the setup, I established what the time constant is based on the specified resistor value in the circuit, and this will help us define what the appropriate delay should be in between readings down to my loop. In the setup, I set the Vin pin low for 5 seconds to let the capacitor fully discharge. In the loop, I have 2 while loops, one that runs from Vin equals 0 to 5, and the other one for Vin equals 5 to 0. So the first one sets the Vin pin to 5 volts, and here we're monitoring the voltage across the capacitor from its initial value of 0 as it progresses towards that 5 volt value for Vin. It increments in that delay read time that I mentioned before, and something important to note is that the delay read value had to be multiplied by 1,000 to set it to milliseconds for the appropriate delay in the code. Once it exits this while loop when the timer equals or becomes greater than 10 times tau, the timer value resets to 0 so it can enter the second while loop, which sets the Vin pin low and monitors the voltage across the capacitor from 5 volts all the way down to 0 volts. Something important to note is that when I run this code and open the serial monitor, it will have a string of my Vin values on the left-hand side and my voltage across the capacitor values on the right. So open it up. Serial monitor, it starts off blank as it allows the voltage across the capacitor set to 0 volts, and then you see the readings coming in. You can see the voltage across the capacitor on the right approaching that 1023 value. And then after the 10 times tau period, it approaches 0, which is what the Vin value is set to during that while loop. And it keeps going on forever, just like that. So here's my processing code. It takes in the 2 values that are specified for each line in the serial monitor from my Arduino code for the VC and Vin values. To create the oscilloscope that you see on the right-hand side, I created 6 thin rectangles that were placed at the appropriate heights based on their 0 to 5 volt outputs. They're accompanied on the left-hand side of the screen by voltage text markings for the user's convenience. I added a legend at the top of the screen that has a green dot signifying that the green pattern on the oscilloscope refers to the voltage across the capacitor and that the red refers to the voltage in. So at the bottom of my processing code, I have a line that will save my tabular data to a CSV file for importation into a program like MATLAB once I stop the data collection in the processing window. In MATLAB, the CSV file is loaded in, and all ADC code values are scaled from 0 to 5 volts. On the right-hand side of the screen, you can see the voltage across the capacitor response for the resistor value of 100 kilo ohms. I added a VC theory plot that mimics the RC simulation at the beginning of this lab report. And I plotted it in green, and it's totally encapsulated by the red VC plot, which shows that it's a great fit with the theoretical data. So I've loaded in a second CSV file into MATLAB for the 10 kilo ohm resistor VC data, and you can see that on the plot on the right that the theoretical plot deviates from the experimental a little more than the 100 kilo ohm data did. In fact, it looks like it reaches the Vin value of 5 volts quicker, which could indicate that the 10 kilo ohm resistor actually had a higher resistance value than what was specified on the band.